How's it going, everyone? Eulier Gonzalez here, and today we're going to talk about is the React Performance, which is a course taught by Steve Keeney, head of front-end engineering at Temporal, which is a durable execution platform. You can think of this like some sort of Kubernetes that covers specific business use case. And the goal of this course is to look at how can we now write React components in the most performant way. And to do that, we need to take a look, or in today's video, I'm going to now walk through the learn section from the React docs as a way to describe that story, okay, of the reason why we use React, how do we get here in the most succinct way possible. So now I can develop not only is this technical communication skill, which is are tremendous, are important, are huge in your journey, but also the hard part or your technical aspect. So the reason or the specific goal of this course, as a way that I'm going to take note out of this course, so you're not going to see is the video from that platform. I already received a flag from that, so I don't want to get in trouble. So it's like, okay, so how can we now structure our hierarchy to make sure that our React components perform as performantly as possible? Learn how to memorize components using the built-in React tools. Learn how to load or learn how to load content or code just as you need it using the lazy function. Concurrent feature of React 18 as a way to understand now that from React 16 we use something called Fiber as a way to now optimize is the tracking mechanism, as a way to make much more efficient the mechanism when it comes to tracking all of this state and when those states change, which components they need to update as a way to render that component and commit the change to the DAO. So I think there's something beautiful as a way to describe that in the most precise possible way. And well, actually take a look at the React Dev tool, which it comes with the components and the profiler. Components are more relevant to development. Profilers is way more relevant to what we care about here in this course, the performance. Okay, and just a quick recap of what are the skills the company are looking for. Yes, how is your thinking process, which is good. Also, your technical communicational skills is like, can I implement your approbation, your explanation? And I think this is something crucial, especially here in a remote settings, because I recognize that if you live alone, it is very, very, very hard, especially for people that work on computers, the computer science or any field where you can work in a remote setting. So if you don't train if you don't train your social skills, you atrophy that muscle. And that's exactly what I don't want to do. And I recognize the importance of actually take notes and record this series of videos as a way to put data practice. And then, what are the best practice to follow? Do you just memorize, or do you know the trade-off? And also the soft skills, which is, hey, are you empathic with others? Do you have patience for yourself and with others? Okay, and last but not least is the domain name and the domain specific knowledge. In our case, with JavaScript, particularly with React. So this course is laid out in this fashion. We got the introduction, then we're going to talk about React rendering, which is one of the focus of today's video, as a way to now make a quick intro and then dive deep into now the learn section from React docs as a way to be able to describe that. So when college or non-technical people, whether it's on the business, shareholders, clients, users, come here and then you need to explain that. You say, all right, now this is it. Okay, I can make all of those complex ideas meaningful to others. And I think this is the role of a senior developer. Okay, what I will argue that any senior as it is. Then we're going to talk about redundant rendering, context, and suspense and transition. But, so this course is for people that want to know how React works. Eventually, they need to know, because perhaps you initially you're writing is your applications, and they are good. You know, they perform great. But sometimes when you're writing other React components, you have some issues. You have your performance penalty. So the idea here is that by understanding that how the React works, you are now come up with some tool set to diagnose this React performance issues, and then apply some of the best practice when you see that. You can think of this pretty much like untying a big knot. So you are going to now pick out all of the threads as you going to and apply all of the techniques that you know for that. Because if you don't do this, which is something that you're gonna learn from experience, is that and this is something that a lot of people actually joking about, is that, hey, how they need to actually write or rewrite their React applications. And quite frankly, is something that is not fun until you have to do that. So to prevent those scenarios as much as possible, all right, that's the reason of this course. So the value proposition, especially on the React performance, is to say, okay, according and also to Steve Kinney, is that not doing things is way much faster than doing things. And there's a corollary from that, which is doing things later is better than doing things right now, which is one of the features that React, for example, with low priority re-rendering, like user first and use transition, allow you to do. Remember that at the end of the day, this is a tool that was developed by Facebook to solve Facebook problems. Most of us don't have that kind of challenge, and if you do, please send me a check, and I'm gladly to join in to your team. So now here we're going to look at also is the diagnostic tool as a way to understand briefly, and which is something that I'm going to see and we're going to see at the end of this course, is that first focus is if the bundle, if the live side bundle is in production, because the React development actually is 4 times bigger than the React tool, the React in productions. And also look at then now at the component hierarchy. Identify if you really are looking for a performance issue. That's where you should start with. Hey, do we have a performance issue? Do we really have a performance issue? All right. Let's go to start is with the production build. Hey, this production build is on production, or we're using is the development. And the other is, okay, now how is the component hierarchy, okay, in your states, because that actually have a huge depend on how you organize that, it will have a huge performance penalty. If there is nothing wrong with that, then okay, then how can we now memorize or using these memorization techniques And the memoization is just a fancy word to say, hey, given a functions that you always receive the same input, you will always get the same output. With the subtle difference that the first time this function is executed, okay, you're going to compute that. You're going to think about it. But in the case of computer, compute. The next time you receive the same input, instead of computing that, you previously stored that and return the value. So for example, if I ask you how many times what is 8 times 8, okay, and you say okay, 72. You take you some time to actually give me the answer. The next time is how many times is 8 times 8? 62. You know, you don't have to dedicate time. The reason of this memorization is that we don't need to spend time in things that we have previously done or we have previously calculated. Okay, that's what we have now, a memory, a cache for that. So far so good. So then we got is using the suspend API to progressively load your application. Is a good idea. Okay. So then so for example, if this memorization techniques that allow us to save time rendering, okay, it's not enough, all right, then let's go to look at the suspense API. Again, all of these are techniques that we're going to apply to untie the node. First, verify that you have the production, that you have the React production bundle, okay. Then let's go to look at the component hierarchy or state. Start first there. The other is that, hey, what are the catching mechanisms that we're using to save us time rendering, which is memorization. And well, how we are using is our components. Can we defer some of them to load them later? Can we load them as we are building our applications by using as a suspend API, okay? Or the transition API when you really need a pickle, or when you really in a pickle. In a pickle, that's quite interesting. In a pickle. When you're really in a pickle. Pickle. In a pickle. Origin of the phrase in a pickle. He got himself in a real pickle. He got himself in a real pickle. Means he has taken actions that have resulted in being in a negative situation that will be difficult to overcome, no matter what he chooses to do about it. Side note: he got. It's a British English. The contraction is that he has got. In American English, in this context, this will be he's gotten. According to this. What does the color green? Okay. Well, according to the, again, this is that you get yourself into a pickle. You get yourself into a pickle. It's like, okay, interesting. Until you really need it, right? Therefore, when, if you're really in a pickle, and I think that's quite interesting. So, this is all of the techniques that first we look at them as a way to at least just have a broad sense that's exactly what we're going to do as we move on. So, because the goal of today's video is to now be able to describe in the most succinct way is the learn section from the React doc, when we are looking first at how do we get here, when we use React. Okay, first is by describing is the UI. So because at the end of the day, React allows us to create user interface, okay, and how lengthy and verbose it is. To anytime you want to create an element in the DOM, you say, hey, create element, okay, and with that, well, you will need to add all of these elements over and over and over, okay. So instead of doing that, yes, so instead of doing that, yeah, so instead of doing that, we're going to see how can we use that. So the point of this, okay, the point of this okay, no, okay. So the point of this, okay, is that now we are okay. So by being able to describe is the by being able to mention is how do we get here with React, and from there, now let's take a look at how we can is describing the UI and how lengthy and verbose is to also anytime you want to add a new element, you have to call the document.create and then append that element to that, you know. So instead of doing that, which is something that actually React is doing behind the scenes by calling as a function create element, so it is much more convenient to use is the JSX syntax, where now we can add is the functionality to the template. We also look at how can we start to define is or conditional rendering, whether it's using if or whether it's using is the curly brackets as a way to say, hey, if this happened, so for example like this, you know, conditional rendering here, hey, if this happened, hey, I want you to now return this, or if this another thing happened, I want you to return this. The idea of looking at this conditional rendering and then how you can now accept props in your components and how you can list elements in your React components is just as a way to understand now how then the React components work. In other words, how React actually look at all of these components or see these components, okay, the render tree. And then we have, and the render tree is important to understand because now once you do that, you can get you can understand how the data flow and also how you can optimize your components. And with the tree dependency, which is now the logic that we add to these components, so we can now instruct which component or which codes to load. So as your application grows and grows and grows, it makes more sense to actually find a way to minimize those bundles that we're sending to the client, to the browser. So these two concepts, okay, the render tree and the tree dependency, now lead us to look at how can we now connect our functionality to the template through the event handlers. So we started to look at that, and then most of the time, because we don't actually is just connecting to the handlers or connecting to the event handlers, we also need to pass in some data, and that's when we have now the state as a components model, a way to now remember things. And the using behind the thing is closures, which is a nice JavaScript features that allow you to access to the outer lexical scope from the inner, as long as you return is a function of a function. So this is something interesting, because as you can see here, once you understand is the fundamental and you're able to describe that to your interviewer, or again college, or any other non-technical people, business people, shareholders, customers, you know, is that now this is very useful for you, because when you talk about now the JavaScript, okay, as a way to know how this actually works, the inner mechanism, it is important to identify, to map what these frameworks that are built on top of JavaScript are doing. And that to me is quite very, very, very interesting. Because with that, a particular approach, now when go back here to React, to the states, and how can we now define this component memory, so we can, anytime we change the state, so we set the state, React is trigger a rendering. And you may wonder, what is a rendering? I'm glad you asked. If you don't do that, no problem. Here's the answer. Because we have now this mechanism that React, anytime we change the state, does for us, which is say, okay, we got now the trigger phase to say, hey, who actually trigger a rendering? And it can be on the initial render, when you actually now call is the create root, okay, or a component state, or any ancestor component state updates. So this is now how it is being triggered. And when React detect that, is say, okay, now it is time to do is the rendering. And the rendering is just React calling your React components functions. So it can be at the root, okay, or it can be when the state, it can be at the component, it can be at the level when the it can be at the component level that perform and state updates. So now React evaluate that, in other words, it called that function and it returns a JSX. And if this JSX actually contains a element or a React component, it will call that functions, and if that output contains also, which is a JSX, that output contain also is a component, a React component, it will call that in a recursive way until there is no more React component. This is something that is cost, okay? Calling these components over and over and over, okay? So because of that, okay, there's some optimization techniques that say, hey, if that component needs to be rendered, it is better to put them at the bottom here. Because if you have now those components that are trigger a rendering higher in your tree, then you are going to then you run into performance issue, because you're going to call all of these components unnecessary, okay? When you only want to change the state. So this is described in the performance here, okay? Like use production build, single file build, use branch as a way to now make that much more performance, or browser. I think, but this is actually quite all. This is actually quite all. And again, this is not optimized. This is not, sorry. This is not optimized, or this is not updated. Yeah, this is not updated. Even though they tell you here, it's like, hey, no, we haven't updated this. But it's this. So React normally re-renders components, and when you anytime you see this re-render a component, it means that it called a component. When that's component state updates. So whenever it is parent re-renders with Mimo, you can create a component that React will not re-render. Exactly. With Mimo, you can create a component that React will not re-render. In other words, it will not call that. So when it is parent re-render, so long it is new props are the same as the old props. Exactly. So you can create a component that React will not re-render. It not will call it, okay, when it is parent re-render, so long as it is new props are the same as the old props. So it's now taking a look at the props, something that we're gonna call that. Such a component is said to be memoized, and that's something interesting. You know, to memoize a component, wrapping a memo and use a value that is returned in a place of your original component, which is great. A React component should always have pure rendering logic. In other words, it must not cause a side effect. This means that it must return the same output if the prop state and context haven't changed. By using Memo, you're telling React that your component compiles with this requirement. Hey React, these components, you're going to call them as long as their props change. If it's not, continue to evaluate other components. Continue rendering other components. So by using Memo, you're telling React that your components compile with this requirement, so React doesn't need to re-render as long as its prop hasn't changed. Even with Memo, your component will re-render if its own state change, or if a context that is using changed. Interesting. Even with Memo, your component will re-render. Your component will be called, okay, if its own state change, or if a context that is using changed. Okay, as long as the inner state, okay, as long as, so this component will not re-render, React will not call them as long as their props doesn't change, or their inner state doesn't change, or you know, or interesting, or a context that is using change. Okay, if you have now, if you have now bind to a context, which is a way of how you can now organize the state change. If that state change, then it will trigger that. That's one of the reasons why context actually introduces this undeterministic behavior when it comes to re-rendering components. Oh my god. Okay, so that was quite interesting as a way to recap that. All right, okay. Memo now makes a lot of sense. Memo now makes a lot of sense. Okay, good. So this is now rendering, okay? Render and commit. Then you got now state as a snapshot. Okay. Render and commit. Okay. Render and commit. So all of that was just to describe is what are the mechanisms, the process that React will go when you re-render a component, when your state change, and React detect that and pass through this process. The trigger, the rendering, which is just only calling those React components, and if the result, if the outcome of them give you, which is a GSX, give you is a nested React component, then you're gonna call that again. Then you're gonna call and repeat the same process. Okay, so what Memo is doing is saying, hey, I don't want you to call this component. Okay, if you want to call this, only do that if the prop change, or if their inner state change, or if the context that is being consuming change. And I think that, yeah, complete. And I get it why this introduces a lot of undeterministic behavior. In why context, in why context, interesting, 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 interesting. All right, makes a lot of sense. Okay, okay, makes a lot of sense. Makes a lot of sense. Ooh, my God, yeah. Oh my God, it makes a lot of sense. Makes a lot of sense. Yep, 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 yep. Okay, 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 okay. Oh my God, yeah. So, that's one of the reasons why I dedicate time and taking. So I focus, find a way to get into the zone. So now, when you have to explain to someone else, you say, "All right, this is it, like this," and when you even have to code this, you know, okay, this is what we're gonna have. This is what we're gonna do. So you know now the inner mental model of this. So, once React call all of your components, then on the commit phase, when to now apply the necessary DOM updates, as long as the React components are different. You know, React only changes DOM now if they are different between renders. If these components are different. So once we're able to understand that, okay, now we look at how can we now think of our state, okay, especially when we want to set the state, okay, to update the state. And thinking then as a snapshot, as a way to say, okay, because you are notifying is React that this is the state that you want to change, okay, it will do some process to manage is the state now. First we look at how now React is managing is the rendering, okay, as a way to call all of these components and then apply the necessary DOM updates to the DOM as long as there is difference between renders known as diffing, okay, known as diffing, the diffing algorithm. Diffing short for difference algorithm is to use to differentiate the downstream for effective or efficient updates. So on that, okay, now when we take a look, yeah, so now when we take a look at the exactly. Yeah, totally. So now that we actually look at this, this was because during the last step, React only update the counting of H1. But again, because we actually getting is this thing called time, okay, and it's actually performing is a render, okay, the input change. So you're going to re-render this, re-render this, re-render this, and so on and so on. But on the commit change, so now this is something that we explained that, okay, and we're talking now about is, okay, how can we think of a state as snapshot, as a way to understand what's going on when we set the state, okay, when we update the state, this component's memory, right? As a way to now is not only pass data to our templates or add some functionality to our components, okay, And the mental model is that when you set the state, okay, you tell React, hey, I want you to change this state, take this order for me, okay, and then React apply the change and give you a snapshot of the state, of the update state. And I think this is quite interesting. This is snapshot as test, okay? So on that, here, this is where you can say, okay, I want you to do all of this, so take all of my orders, okay? Take all of my order here, and that's when you pass all of these orders, okay? And then now React say, okay, I can now enqueue all of these states, all of these orders to render, okay, into a batch, aka enqueuing state, or queuing a series of state updates. So now we can is not only tell React what is the state that we want to update, but also we can is do before trigger a render, what will be all of this series of state change before actually trigger an update, okay? And all of them happened at the event handler. It's on the event handler, and when you evaluate that event handler function, it say, all right, now I'm going to apply is the rendering, okay? So here's what you can say, okay, let me update this state, this another state, this another state. You can also is not only update the current state of that, but also to update sequence of states as a way to say, hey, I want you to now is update the previous state with this new value using the arrow function. And I think this is quite beautiful. Totally beautiful. Because now with that we can say is, so for example here, we can say is things like this. So after an event handler is being run, it's going to evaluate is the last one. Okay, hey, I receive all of this state, okay, and then I'm going to apply is this state. However, for example, let's say you're going to you have two numbers here, say number 2, so number 2, okay, and here you say is, hey, this is the H number 2, okay, and I want to apply all of this state and say, hey, now let me do this, do the set number 2, all right, which is the previous value of, and I want to apply that to 5. So what will be the end output of this is the evaluation of all of this state change. So React say, okay, I'm going to evaluate all of this and this and that, okay, because you are batching here state change. The last one is what really matters for this state change, which is 42, but for the set number 2 is going to add is 5, which is 5 here and 42 here. You know, this is now how you can think of the state as a snapshot. So again, you're indicating is, I want you to now update this state, update the same state, and I want you to update another state, and React take that state, okay, and then give you the snapshot of the new state. It is also important to understand that you will only get the state update, okay, the state's value, or the state value updates happens after the component is rendered, after the component is called, which is one of the different here, okay. For example, which is something that they mention here, is a state as snapshot, okay. is that using its state at a time of the render. And then you say setting states only change in the next render. So and a state variable never change within a render. Okay. So those state change never change. So those state variables never change within a render. So this is one of the things that are important to recap as a way to, when you now look at updating objects in a state and updating objects in arrays, they have their own peculiarity. The TLDR of this is that you should always return is a new state to the snapshot. Okay? And if you want to actually return some nested state objects, you can use this tool like immer, for example, that allows you to say, hey, let's go to define this state as an object, where you're going to define is the object that you're going to receive, or an array. And the entire reason to do that is you must always apply state change. Okay, you must only apply a state change like so. Local mutation is fine. Okay, you must only apply is state change here. In general, you must is always create a new state when you're going to update your state. Okay, this is also part of the following is the functional approach, the functional programming, as a way to, instead of mutating object, which is a practice that you do in object-oriented programming, as a way to now say how can we organize data and its relevant functionality into one bundle, and then we can extend its functionality, or we can have access to the functionality, but to cover a particular use case, aka subclassing. So now we get this. The point is great. So as you look at how can we now increase is our or how can we now add in the interactivity, okay, using the event handlers to connect that to our so using or reacting to events using the event handlers. And then how can we use a state as a way to now connect those events to a particular state, and what states are, which is a component's memory, a component's memory, and how these components actually works behind the scenes by taking now is your instructions, your orders, apply the change, and then give you a snapshot. And now how this state change when you want is to actually is show a new state, when you want to actually render a new state, what is the mechanism that is doing behind the scenes, as a way to say, hey, this new state here, or this, or because you changed the state here, this is the process that I'm going to follow as a React to actually apply those changes so the users can see the new element change or the elements on the screen. Okay, the state updates, and that is by going through the trigger, render and commit, and the trigger is being is triggered by on the React level, on the root level, okay, as a way to now adding all of these elements here, or with the component states updates or any of its ancestors. And on the rendering phase is saying, okay, which happened is the initial rendering, okay, when you say create root, or if subsequent rendering happen, which is React will detect what component states updates, okay, and then we'll call that function, and the return of that, which is a GSX, it will now evaluate, hey, do we have any React components there? If it is, all right, let me actually repeat the process. Call that function, check if that component actually state change. If it is, all right, then now let me take a look at the GSX. If that GSX, which is the return of that function, if that contain is a React component, all right, that's going to do that again recursively. And then this is one of the reasons why optimization is why the component hierarchy is so important here. When those renderings happen, because now when you do that, it is your job, or it is now the React job to decide, okay, which one of those components actually are different, because I'm going to apply now the bare minimum necessary DOM change to that. I'm going to commit those changes to the DOM. So then we'll look at how now can we enqueue states as part of that. And lastly, how can we update objects, object states, and array state. So finally, we are here in managing states. And I think this is quite interesting, because this part or this section is telling us, hey, once your application started to grow, you need to find a way to manage your states, okay, in an organized way. So do you want to now be more intentional about how you're going to recreate your React components, how you're going to now define your states, which is managing your states, to stay organized and to understand how the data flow flows, or to understand now how the data flows between components. So eliminate redundant or duplicate state is a common source of bugs. So in this section, we're going to see how to structure your components well, how to structure your state well, and how you keep your state update logic maintainable. And I actually slow down a little bit here, because as we look at how we can now update the states, it is also important how to make that update state or state update logic maintainable, okay? And then how now can we pass down data to distinct components, okay? So this is the three things that are relevant, and all of them is involved is the know-how. All of them involved is the know-how, the mechanism. So let's get into this. How do you think UI as a state change? Okay. So with React, you won't modify the UI code from directly. For example, you won't write commands like disable the button, enable the button, show the success message, etc. Instead, you will describe your UI you want to see for different visual state of your component: initial state, typing state, success state. So now you're going to be more declarative instead of imperative. What are the state that I want to show? Pretty much like like a designer create the mocks. Okay, it show you is different states, and this is also a combination of the computer science, the in the computer science, the state manager, or the state 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 machines, okay, or finite state machines, all right, which is a combination of this finite state machine o un autómata finito, finite state machine, teoría de autómatas, sistema combinacional, autómata finito, autómata con pila, finite state machine y máquina de Turing. They can know all the possible states for that. More machines and mainly machine. The circuit diagram for a 4-bit DLL counter. The diagram. That's actually interesting because this is now a lower level. At lower level. Base programming, event-driven finite state, virtual finite state machine, state design pattern, finite state machines and compiler. Finite automata are often used in front-end of programming language compiler. But when they say this definition at the mathematical model, finite state machines can be subdivided into acceptor, classifier, transducer, and sequencers. Generate a pre-trained transformer. But exactly, what is it counting? A state is description to status, waiting to execute a transition. Yeah, but what is considered a Turing machine? A finite state has less computational power than some other models of computation, such as Turing machine. The computation power is a mathematical model of computation, describing an abstract machine that manipulates symbols on a string of tape according to a table of rules. Despite the model's simplicity, it is capable of implementing any computer algorithm. The machine operates on an infinite memory tape divided into discrete cells. A physical Turing machine model, a true will have unlimited tape on both sides. However, physical models can only have a finite amount of tape. The incomputability, man, of the Einsteinian problem, Einstein's problem. Turing machine proved the existing of fundamental limitation on the power of mechanical computation. Yet Turing machines prove the existing of fundamental limitation of the power of mechanical computation. Of course, while they can express arbitrary computation, their minimalistic design makes them too slow for computation in practice. Real-world computers are based on different design, unlike Turing machines use random access memory. Turing completeness is the ability to computational model of assisting its instruction to simulate a Turing machine, an infinite memory. It's a machine that has an infinite memory. Describing an abstract machine that manipulates input or a string of tapes according to a table of rules. And the Entschuldigung problem. In mathematical computer science, the Entschuldigung problem is German for decision problem. Entschuldigungsproblem. Entschuldigungs. Eins, End, Ends, yeah, Ends, Entschuldigungs. Entschuldigungsproblem. Entschuldigungsproblem is a challenge posed by David Hilbert, a German mathematician and one of the most influential mathematicians of the 19th and early 20th century. Holy hell. And Wilhelm Friedrich Ackermann. In 1928, the problem asks for an algorithm that considers as input a statement as yes or no, according to whatever the statement is universally valid in every structure. By the completeness theory of first-order logic, a statement is universally valid and it is often thus. Alonso Church and Alan Turing published independent papers showing that the general solution of the Entschuldigung problems is impossible, assuming that the intuitive notion of effective calculable is captured by the functions computable by a Turing machine, or equivalently by those expressible in the lambda calculus. This assumption is now known as the Church-Turing thesis. And anyway, what we were looking is now at how everything is related. And that's why you need to shrink a little bit that. So cut the fluff here. Cut the fluff. So, yeah. Alright. So cut the fluff here, and looking here is at this overview, okay, of how can we managing state as our application grows, and we need to know how to organize our states and the data flow between components. So, because redundant state or duplicate is a common source of bugs, we're gonna see now how to structure our state, how to keep the state updates maintainable, and see how can we now pass data, or how can we share states between distinct components. So here we're looking at the reactor to input with state. With React, you won't modify the UI from code directly. For that, here's a quick form building using React, like so. It's explaining that trivially here. All right, okay. So ready to learn this topic? Reacting to input with state. Yeah, let me read about this. So with React, you won't modify the UI from code directly. For example, you won't write commands like disable the button, enable the button, show the success message. Instead, you will describe the UI you want to see for different visual state. You're going to describe the UI from different using visual state, okay, of your component. Initial state, that's one of the reasons why there's a company called Storybook. The Storybook. Okay. That's why there is a company called Storybook as a way to look at that. As a way to look at all of the different states that happened here. Development, interaction testing. visual testing. Okay, that's quite interesting. Interesting. And documentation here. Develop durable user interface. Why build UI in isolation? But again, this is for big companies. One component state can have several states or stories. It can now not only each one of those stories can have different state, okay, but it need to render is on different browsers, and also on different viewports, and also calculates different disabilities. Build UI in isolation. And I get it why they have this, but again, this is useful for bigger companies. But it's not necessary to develop complex UI faster. It's for those big companies, man, where now making a change is quite slow. Man. Making a change is very, very slow. Even buyer, what? DocuSign. Storybook app. Maintained by Chromatic. Special thanks to Versal and Sanity. Yeah, but the question is like, how much does it cost, bro? They don't tell you. Okay, pricing. Visual test coverage for lean teams. But again, this is for this is for business, bro. This is for business. This is their audience. Business, bro. Okay. Business, bro. Business. Okay. Business. Business. Interesting. Very, very interesting. Okay. So that's one of the reasons why I'm dedicating this time to look at this. It's as a way to say, okay, here in managing a state, we are looking is that as our application grows, the complexity and the harder to debug our app can be horrible. It can make our life miserable. And if you don't follow certain guidelines about how to structure your state, how to define a maintainable state update logic, and how now to pass states to distinct components, then you will have long nights. You'll have long nights. That's all I can say. You will have long nights. Yeah, you will have long nights. You will have long nights. Okay, sorry. Okay, so reacting to input with state. So reacting to input with state. So with React, when you modify the UI from code, reacting to input with state. Okay. Reacting to input with state. Okay. Okay. Reacting to input with state. Again, this is the mental model here. So React with React, you won't modify the UI from code directly. For example, you won't write commands like disable the button, enable the button, and show the success message, etc. Instead, you will describe the UI you want to see the different visual state of your component. And this is now when you want to write is maintainable React component, not React app. We look at how can we write is maintainable React apps, but when it comes to write maintainable React components, you can start from you must start from the basics, and also you must look at how you can write now reusable JavaScript functions, JavaScript applications, but in our case, React. Okay. Here, instead, you will describe is the UI you want to see. You're going to describe is the UI you want to see. Okay. That's right. You're going to describe is the UI you want to see. Mm-hmm. 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 Mortgage repay calculator, contact for hand games, recipe page, social link, blog preview, and that kind of thing. Okay. Mm-hmm. Age calculator app, working landing page, result summary component. Mm-hmm. Single page for developer portfolio. Mm-hmm. Mm-hmm. Here's there is nothing with React, right? No, because this is pure and plain. Mm-hmm. Okay. Interesting. Mm-hmm. Oh, mm-hmm. Okay, okay. Mm-hmm. Mm-hmm. Okay. Mm-hmm. Job City. Storecast frogget. Mm-hmm. Exactly. Mm-hmm. Okay, 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 okay. Mm-hmm. Mm-hmm. That's very interesting. Mm-hmm. Mm-hmm. Okay, okay. Why am I looking at this? You may wonder. Um, it actually drew my attention. I think the using is 3 years ago, 1 month ago. Because of course they're actually looking for people. As I say, hey, please, we know that we need that you need this kind of technology, bro. Please, please. Testing library, React DOM, markup, React Redux thunks. But they're using it Redux, not Redux RT key. Okay. Source, index report, web vitals, setup tests, the store, the define, or even the define is the store as well. And the components here. As well as a counter here. Is limit reached. Mm-hmm. Mm-hmm. Okay, 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 okay. That's yeah, yeah. That okay. So by looking at now this, okay, especially that the way how now you create or you managing state is by first defining is by defining is your UI, defining your UI states. Okay, hey, how this component should look like. What is the initial state? What is the typing state? What is the success state? Okay, and then you choosing the state structure as a way to avoid being redundant or to eliminate common problems like being redundant. Okay, choosing the state structure. All right. If there is unnecessary state, it is easy to forget to update and introduce bug. So remove unnecessary states and then just compose them. You can remove and simplify this by saying, hey, let's to compose this when we run this. Okay, and anytime it changes, you say, all right, good. Choosing the state structure, sharing state between components, okay, as a way to pass them with props. So sharing state between components, okay, and when any time of these components change, it will re-render that. It means it will call the React components, which is a JSX function, preserving and resetting state. So when you re-render a component, React needs to decide which part of the tree to keep and update, and which part to discard or recreate from scratch. In most cases, React automatic behavior works well enough. By default, React preserves the part of the tree that match up with the previous rendering component tree. However, sometimes this is not what you want. In this chat app, typing message and then switching to the recipient does not reset the input. This can make the user accidentally send a message to the wrong person. Exactly. So preserving and resetting state. Remember that after all, we are defining is user interfaces. Okay? And now we're looking at how can we managing state. Preserving and resetting statements. Say, hey, but you are not, say, let's go to say to Tyler or Alice. But you are now clean that up. That's when we are now. That's when we have that particular component, which is or that particular developer approach, which is okay. You're gonna have is your renders, your commit phase, as well as your cleanup or preserving and resetting state. Okay, makes a lot of sense. Yeah, makes a lot of sense. This tells React that if the recipient is different, it should be considered a different chat component. React lets you override the default behavior here. Like chat key email. To email. It should be considered as different chat component that needs to be recreated from scratch with the new data and UI-like inputs. Now switching between the recipient resetting input files, even though you render the same component. React like you override the default behavior and force a component to reset its state by passing in a different and to reset the state. Okay, and to reset the state by passing in a different key, like chat key email. This tells React that if the recipient is different, because at the end of the day, what it's doing is that if the props are different, I'm going to now re-render this chat component. I go now to re-render this chat component. Because if you pass it to, it say, hey, you're not mutating the Okay, because your passing is the 2, which is a contact 1. Where do you get this contact? Oh, because this is contact list. Okay. On select. Okay. But because you are now telling with the key here. React like you override the default behavior and force a component to reset its state by passing in a different key. Enforcing React like you override the default behavior and force a component to reset its state by passing in a different key. So if you're passing a different key, you are forcing these components to re-render that. Which is a key property. This tells React that if the recipe is different, it should be considered a different chat component that needs to be recreated from scratch with the new data. And UI like inputs. Now switching between the recipe resets the input field, even though you render the same component. But this is a way to force a component to reset its state. This is a way to reset. Okay, this is a way to reset its state. Reset its state with the key here. Extracting state logic into a reducer as a way to now make the state updates maintainable. Make your state update logic maintainable. Components with many state updates spread across many event handlers and get overwhelming. Components with many state updates spread across many event handlers can get overwhelming. For these cases, you can consolidate all the state update logic outside your component. So for these cases, you can consolidate all the state updates. For these cases, you can consolidate all the state update logic outside your component in a single function. What a fucking single Components with many states spread across many event handlers can get overwhelming. Okay. For these cases, you can consolidate all the state update logic outside your component in a single function. Okay. So all of these cases, you can consolidate on the state update logic outside of a component. In a single function called reducer, your event handler consists because they only specify the user actions. At the bottom of the file, the reducer function specifies how the state should update in response to each action. Okay, so now you have your task reducer. So use reducer in the initial task. Where is the initial task defined? Maybe a function. The initial task reducer. Oh, and the initial task. Okay. So hey, the initial task is visit Kafka down. Okay, the initial task and the task reducer. Where now the task reducer, which is a function outside of this, where now give you is this maintainable state update. We do the action type like this. Hey, when this action type is this, or change, or delete, I want you to now do this. But also returning is a new state, and that makes a lot of sense. Similar to the filter. This actually makes a lot of sense. Okay, in passing data deeply with context. We get it, bro. Passing data deeply with context. Usually you will pass information from parent components to child components via props. This is known as prop drilling. But to prevent the props drilling, now here in React 18, they say passing props can become inconvenient if you need to pass some props through many components, or if many components need the same information. Context like you lets the parent component make some information available to any component in the tree below it. Exactly. No matter how deep it is, without passing it explicitly through props. Here, the heading components determine its heading level by asking the closest section for its level. Each section tracks its own level by asking the parent section and adding one to it. Every section provides information to all components below it without passing props. It's just through context. So now you got all of this, okay? You're rendering all of this. Where now your section here, by defining, is a level context, which is your state. And I need to look at this, bro. And I need to look at this. Oh yeah, it is. And I need to look at this. It's like, okay, I get in theory, but I know what is going on in practice. Okay, no problem. Section class name section here. Level context dot provider. Level context dot provider with this value. And you know what to render is the children that we're receiving from. So on the headings, when we're calling the headings, we are now going is to do this. Instead of defining all of this switch case, holy shit. Okay, if case is 0, I want you to now render this one with the children's data that you receive of this dynamic content. 1, 2, 3, 4, 5, 6, we want you to render is 6. Okay, so we want you to render is that. Scaling up with reducer in context. Exactly. This reusable, okay, scaling up with reducer in context. This reusable update logic. And now this way of how can we pass data to distant child, to distant components. Okay. 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 All right. Let's get into this. Let's get into this. Let's freaking get into this. Dale, dale, dale. Ah, marico, ¿y tu papá todavía está aquí? Coño, qué loco, qué loco. ¿Qué tal han sido estos días con tu papá aquí? Ha sido toda una experiencia, la verdad. Nos, yo no sé si ustedes se hubiesen imaginado que iban a estar en Argentina, Buenos Aires, en el 2024. Ok. Sí, estoy en Mercado Sí, estoy en Cava, pero solamente que como ahorita no tengo mucho tiempo, entonces si te puedo hacer esa reserva y te transfiero, entonces sería mejor, así se agiliza ese proceso. ¡Qué maravilla!
Ay, yo perfiladito, yo. Always man. Always man. Always man. Always man. Always man. Ay, marico, man.
All right. Here we are, here we are, here we go. All right. So here we are, looking at the reacting to input with state. And again, this is part of the managing state. All right. So because now we are quite familiar of how do we get here, okay? We're going to see this. So React provides a declarative way to manipulate the UI, because most of the time we know that the way how can we do that is by telling explicitly what to do and how to do, which is a great thing. I really love that, because now you have much more control of what's going on. But when you want to create now applications that are scalable, or as you component started, or as you now starting to implement, or as your JavaScript application is starting to grow and grow and grow and grow, then becomes quite hard to keep up all of the states. Not to mention is which element needs to get rendered properly for that. Uh, so what happened here is that now React with the states, it allows us is to provide a way of how can we now declare UI pretty much like the designers define their state. Okay, so instead of manipulating individual pieces of UI directly, so for example, get the document get element by ID from this list, get element by ID to the element list here, and that kind of thing, and so on and so forth. Okay. Now, instead of actually having to manually is to manipulate is the UI elements, you can describe the different UI states as component. Okay, so hey, how this component now will look like? How this and following is also the atomic design, where you start with your molecules, okay, which is actually how all of this industry actually has evolved. When you start with your atoms, then molecules, then organism, then pages, then websites. Okay, and the idea here is that when you starting to describe is all of these UI states, right? Instead of actually you having to manipulate those elements individually, which is something that you can actually here, is to write application without need to rely on any JavaScript or any front-end framework. That idea was to me quite compelling, because at the end of the day, that's exactly what you want. It's like, I want to build this kind of applications without perhaps jQuery, okay, to make our life much more simpler with that, perhaps with jQuery, okay, perhaps with jQuery, yeah, perhaps with jQuery, perhaps with jQuery. I think they're gonna launch that lightweight footprint, CSS3 compliant and Chrome browser. Download jQuery here. I think the new way JavaScript. Your own jQuery. Build a jQuery release file. Some example model can be exclude or include are Ajax, script, JSON, CSS, show high, deprecated dimension effects, event trigger, offset, wrap, the selector. But I think there is no new about jQuery 4, right? Do we have anything here on the wiki? Oh, exactly. jQuery 5.0 event design. That's quite interesting. Oh, by the way, let me actually turn off the light. Like this. All right. Interesting, but again, this is not what we care about. We care is about React. Okay. So, so because of that, all right, this is now how you can is differentiate between how you now have to describe your UI element without React by being imperative, which is pretty much like you're telling It's like imagine you writing, imagine writing, exactly. Imagine writing next to someone who is telling you to turn where to go. Okay, hey, turn here, turn there. No, then they're gonna tell you where to turn as you move on. But now with the particular approach of the React, is now more declarative. Hey, I want to go there, but you don't care about how it's been doing. You rely on that he's gonna take the shortest path or the best route. So this is one of the reason, or at least the sales pitch from React people, when they say, "Hey, let's go to define our state in our components, pretty much like the UI designer does." And the reason of that is because now it's much more easy to maintain and to scale this kind of applications in theory, okay, rather than doing that in an imperative way, okay, because now you have to know and control which one of those states change and when that changes or how long it changed, you know. So with React, with states, now you have this ability by delegating is to the React to say, hey, this is the user interface that I want you to render. This is the state that I want you to render. So the TLDR of React is that I got a state that I want to generate view out of this. Okay? Pretty much like UI states that I want to generate a view out of this. And this is now how, based on the managing inputs or reacting to input with states, is all about. But this is interesting, reacted to input with state. Okay, thinking about UI declarative, you have seen how to implement a form imperative above. To better understand how you think in React using this mental model, you will walk through re-implementing this UI in React below. So identify your component's different visual state. So identify, for example, the case of a button, identify all of your different visual states. Hey, how this component should look like, right? And I think this is where the value proposition came here. And value proposition is something that a lot of those companies are looking for, are saying, hey, please, I want you to add this for us, okay? Especially if you're going to manage is large code bases. That's when when you look at the storybook like this, storybook, it makes a lot of sense for a lot of those developers to say, hey, yeah, now let's go to actually have a documentation where we can look all of our UI components and see how those components behave and what is the logic behind that. So we can not only is development there, okay, see what changed, how that changed, but also do interaction testing and visual testing. That's a way to get a documented, a visual UI, a visual document about this. Yeah, I think, again, this is quite interesting for large code bases. You know, this is very compelling for large code bases. And it all starts with the idea here that when you're managing states, okay, as your application grows in complexity, and then you need to find a way of how you organize your state and your data, because being redundant with your state or not clear or not removing state is one of the main sources of bugs. So we need to look at how to how to structure your state as well as how to structure, and as well as how to keep state updates logic maintainable, and how can we pass now down data to distinct component. This is now slowly to resonate with me. It's like, oh, okay, it makes a lot of sense. So for that, we're looking at that reactive to input with state. Mm-hmm. So we talk about is the imperative programming. We also talk about is the we talk about the imperative programming. We talk about is the declarative programming, and how now by telling what to do, you don't care about how it's gonna do. It is important to understand how it's gonna do up to a certain point, but you really don't care about it. You are delegating that to someone that actually is more capable on that. So let's. And this is one of the economy at scale when focus of the intensification of labor. Hey, you're good. You are good doing at this. Please focus on doing this, and so on. And I think that's quite interesting. Very, 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 very interesting. Oh my God! Yeah, you don't have it yet. But in any case, so thinking about UI declarative, right? So it's like, so now the React gave you is a mental model of how to do that. Reacting to input with state. So first, you're seeing how to implement a for imperative above. To better understand how to think in React, you will walk through re-implementing this UI in React below. So this is now the mental model. This is now the way of how React does what it does. Okay, and they encourage you to do this. It's like first, identify your components' different visual state. Then determine what triggers those visual states. Okay, as a way to connect that. Hey, this actually trigger is this. It's also all another interesting thing to actually write it down as a way to look at that. Represent the state in memory. Okay, makes sense. So identify your different visual state. Determine what trigger and state updates, okay, or the state change, okay. Then represent the state in memory using useState. Okay, hey, this is the state for this visual state, okay, and I know what will trigger that. I determine what will trigger that state to change, and remove any non-essential state variables as a way to eliminate redundant stuff, and then connect the event handler to set the state. So with that, okay, so step one, identify your components' different visual state. You can pretty much think of this as state machines. When you have now several states, which is a combination between the computer science terms of state machines, okay, or finite state machines, okay, as a way to define is that, hey, these machines can have several states. So for example, like traffic lights, okay, they can be red. I really love it. They can be red, they can be white, they can be red, they can be yellow, they can be green. Okay, a good way to representing this. All right. Okay. Again, all of these are human-made devices, state devices. If you want to take a look at nature, you can say, okay, there is now day and light, date and night, and all of these different states that happen across those, all of these substates. The idea here is to first identify your components' different visual states. Okay. So first, you need to visualize all of the different states of the UI the user might see. For example, empty. Phone has disabled submit button. Typing, submitting, success, and error. And I think this is something quite important as a way to become someone that can provide value not only for one company, but for yourself as well. Mm-hmm. 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 Okay, so first we're defining is the different visual state in our components. Hey, it can be empty, it can be typing, it can be submitting, success, and error, right? Just like a designer, you want to mock up or create mocks for the different state before you add logic. For example, here's a mock for just the visual part of the form. The visual mock is controlled by a prop called status with a default value of empty. That's right. So when that value changes, you could call that props anything you like. The naming is not important. Try editing the status to empty or success, and you will see how now when that React components change, okay, it triggers a rendering, which means it triggers that React call this React component, okay, and the return it triggers a render, which means that it called the React component when that state changed, and the output of that function, if that contains any other React component, then it will call those React components and do the process again in a recursive way, meaning until there is no more React components. And then on the commit phase, it's going to apply the necessary DOM change if there are difference between React components, or if there are different renderings. Mm-hmm. Okay. So in this particular case, if we change, of course, this to success, it detects that change, passing from that mechanism, from the render. Let's gonna call this the render and commit phase. Okay. The render and commit phase. The trigger rendering commit phase, and then now apply the necessary DOM updates so you can see this. So far so good by describing it what's going on. And so here exactly. So not only on state but also on props. And if that prop change, then it trigger a rendering. Okay. All right. So you could call that prop anything you like. The naming is not important. Try editing status equal to empty, as you can see. Here's a more fleshed out prototype of the same component, still controlled by the status props. Oh, but this is a more fleshed out prototype. A more fleshed out prototype. So for example, as you set is now the error okay, what it's gonna do is to show is that, but I think is status error. Interesting. Oh, I was to modify the run instance. Exactly. So now you are prototyping is all of these different visual states in your component. Okay. Identify the visual state components. Okay. Display many visual state at once. So if you have a component, if a component has a lot of visual states, it can be convenient to show them all at once. That's why we have solutions. That's why we have solutions like storybooks. Mm-hmm. 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 status is equal success. Mm-hmm. 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 Okay, displaying many visual states at once. Empty, form typing, empty. Exactly, it's a way to define all of this. For submitting, for success, inform error. So pages like this are often called living style guides or storybooks. Again, all of this, the entire reason of using is the storybook. If you're applying to have or to work with a bigger company that actually is using that contains a lot of components, and now they need to manage the complexity of these applications. It's gonna call it, for example, Adobe or that kind of companies. It's like, all right, it makes much more sense to define or to determine all of these different visual states using storybooks for that. Okay, as a way to know what are the possible combinations of them. And again, this actually requires a little bit more effort, okay, for the creator, for the components, okay. But again, the idea here is that you want to develop rapid prototyping. It's not necessarily be perfect. It's actually doing quick iterations. Step 2, determine what triggered those state change. Exactly. So first, identify your different visual UI state. Okay. Step 2, determine what trigger those state change, whether it's human inputs or computer inputs, like network responding arrive, timer completing, and image loading. Okay. So determine this. In both cases, you must set state variables to update the UI. For the form you are developing, you will need to change state in response to a few different inputs. Exactly, you must set the variables to update the UI. Changing the text input, human, clicking on the submit button, human, successfully network response, computer, failed network response. Notice that human inputs often require event handlers. So to help visualize this flow, try to draw each state on paper as labeled circle, and each change between two states as an arrow. You can sketch out many flows this way and sort of bugs long before implementation. Empty, start typing, press submit, submitting, network error and network success. This is all of the possible scenario here that can happen. And then step 3, represent the state in memory. Exactly, represent the state in memory use with use states for that. You can also represent all of these different possible states, okay? And then remove any non-essential state variable. Hey, does this cause paradox? Is this, can we now reuse some of this information, okay? Can I get the same information from the inverse or another state variable, right? Is submitting a success, is error, is typing, is empty. say answer, set answer, error, set error, status, set status. Eliminate impossible state with reducers. And now here when we are describing is the when you are representing is the state, when you're representing is the state in memory with use state, that's when now you have this reducer function. That's when now you have to find a way to make it much more easy to maintain those state change. To trigger this UI visual element. These three variables are good enough representation in this form state. However, there's still some intermediate state that don't fully make sense. For example, a non-null error doesn't make sense when status is success. To model to state more precisely, you can extract it into a reducer. You can extract them into a reducer, eliminating impossible state with a reducer. And that is by using is a switch case. Connect the event handler to set state. Okay. Connect the event handler to set state. Exactly. And then connect the event handler to set the state. It's like, hey, which one of them actually create a new state for that? Okay. And then going to set the state for this. All right. Okay. Good. Good. So when you set that, in which city is the billboard that turns air into drinkable water? You call this submit form here. You are wait for that. Which is a promise base, and then you got this. Okay. So let's go to do this. So challenge 1: add and remove CSS class. Make it so that clicking on the picture remove the background active CSS class from the outer div, but adds the picture active class to the image. Okay. Clicking the background again should restore the original CSS classes. Okay. 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 So again, defining the states. First, identify all the different states. Identify all the different UI states. In this case, it is background active or picture active. Okay, this is the possible state. Background active, exactly. Background active. Okay, identify the possible different state. Background active. So it's gonna do this. So our possibles are, this is the UI state, right? Const UI state. Okay, determine the UI state, which is background active here, background active, and the picture active. Okay, and then picture active. Okay, this is the two possible state. Background active, but add the picture active to the class here. Alright. Now so first is determine the different UI states. Then what trigger those state change. Okay? So identify your components different states. Identify your components different state change. Okay? Then determine what trigger those state change. Okay, in this case, what triggers? So triggers here, determine what trigger those state change, and then he will say, okay, now let me exactly make it to clicking exactly on click. Remove the UI 0. Okay, remove the background active. On click, remove the UI. Okay, so determine what trigger those state change. Okay, but add the picture active class to the image. Okay, on click, remove the background active in the div. Okay, that's right. And on click, okay, and then on click, yeah, and then on click, okay, add the UI, the picture one in, yeah, the picture one class. Exactly. Removes the class in the div, and on click add the UI class to the image. Okay. So far so good. We have identified the different UI state. So first we identify. Okay. So first you identify. Okay. So first you identify is the UI state, is the different UI states, the background active and the picture active. Okay. Visually, you should expect that clicking on picture remove the purple background and highlight the picture border. Hello. Okay, visually you should expect that clicking on the picture here, clicking on the picture, remove the purple background and highlight the picture border. So, exactly. So visual state, remove, or like to remove purple background, remove purple background and highlights picture border. Okay, so visually you should expect that clicking on the picture remove the purple background and highlight the picture borders. Okay, clicking outside the picture, okay, remove, okay, clicking on the picture, exactly. So clicking on the picture, I'm gonna make this here, Okay, clicking on the picture, remove the background. This is our state. Clicking on the picture, okay, yeah, the different states. Clicking outside the picture highlights the background, but remove the picture border highlight. Okay, so visually you should expect that clicking on the picture, remove the purple background. Okay, which is purple background, remove purple background, and highlight picture border is this one. Okay, and the other is, well, clicking outside, remove purple background and highlight picture borders, and highlights the background. So highlight, exactly, highlight the background and remove picture border. Okay, remove purple background and highlight picture border. Highlight the background and remove picture border highlight. Okay, so now we define all of these two states. The other is that triggers. What cause, to determine what cause is those state change. And then you define is now your states in memory that represent those UI. Okay, and it can be is cons highlight, cons highlight here, for example, that now represent those states. All right, so for example, highlight is highlight here, use state, highlight here, and well, we can say is this one. You can say, hey, because now we're using GSX syntax, you can say, hey, and so if the highlight, okay, if the highlight exists, I want you to now show the background, right? Highlight. You can say highlight background. Okay, highlight background. So if that exists, highlight the background. Otherwise, remove this. Otherwise, only show this, which is this. For real. Otherwise, do this. Come on, man. Like so. So initially, it'll be false. So highlight background here is this one. User state, okay. Yes. Import, and I think that I really love about this because it's now being more precise as a way to say, hey, how do you get this? Where do you get this, right? Use, my God, use a state from React. Okay, there you got it. Anyway, okay. So yeah, all right. So the other is that now that I represent is the state in the UI, okay, now that I represent the state in memory with use states, okay, now that I represent the state in memory with use state, okay, now it is time to remove any unnecessary or non-essential states, okay, and then connect your event handlers to set the state, okay. In our case, when we click on the picture, which is here, when we click on the picture, on click, right? When we click on the picture, yeah. Now we're going to call is the this function, okay, and I'm calling is this. We can do is this. We can say set, because at the end of the day, this actually is receive is the highlight background and set highlight background. Okay. So on click, I want you to now set the highlights to false or to true, right? But because you cannot trigger this kind of thing, it expects a listener. That's when you have to do something like this. Flying. Why do you have to, oh my god. For real? Oh, there you go. You have to do this. So hey, I want you to now set this. So now true. It's a reserved key, bro. Okay. Exactly. And then now that's going to actually is on click set this to false. So when we now click in the on the image, we would like is to now attach is we would like is to so when this is false, okay, if this is true, we are highlighting is the background, right? And we are also here we are saying is well, if the highlight here, highlight background exists, well, it'll be is a if that is true, we want to show you only the picture. Otherwise, we want now to show is the picture active class to the image. I think it's this one. There you got it. So now define is the logic here. God damn it. It's this one. Okay, when we click here, clicking outside the picture highlights the background. Okay, clicking outside the picture highlights the background. But remove the picture border. You should expect that clicking on the picture, remove the clicking on the picture, remove the purple border. Okay. Clicking on the picture, remove the purple border. Background, highlight background. Okay. Clicking on the picture, remove the border logic here. Okay. Exactly. So clicking, exactly. Visually, you should expect that clicking on the picture, remove the purple background. So it means that initially, okay, clicking on remove the purple background. Okay. By saying is this. Use stay here, and then clicking on the input. So you should expect that clicking on the picture, remove the purple background. Clicking on the input, remove the purple background. Okay, let's continue. Remove the purple background. So initially is true. And then, no, we want to remove this. We want to remove this. Exactly. Okay. And clicking outside of that, but clicking outside of the picture on the background, remove the picture borderline. And now, here, you say on click, and then clicking on here, exactly, and clicking on this, set highlight background to true. but because the event is bubbling, but it's because the event now is bubbling. So what happened here is that I want you to prevent that behavior, prevent default, now what happened here is that when we click outside of this, it's calling this, and then it's calling is this event bubbling. I want to prevent is the bubbling effect. Stop propagate, exactly. But in my case, it's like stop propagation from here. Stop propagation. Makes sense. And on the pattern, there you get it. Propagation. Exactly. But as you can see now, what you're doing is like, okay, because now there is something called event bubbling, that we call an event nested here. What happens that is going to call is all of the on click or event handlers, especially on the on click, not all of them, but on the on click, is going to call all of them, so forth and so forth. So to prevent that, this is how can we now define this logic. So it's like on the child, you say, hey, stop propagation, and then you do this. Or alternatively, you can return two separate chunks of GSX. Okay, this is now my particular approach. Okay, this was now my particular approach. But you can define now as UI. But now you can define is like UI events here. And I think that'll be much more readable. To define all the possible cases. Yeah, that'll be much more readable. That's a way to do that. By saying is, okay, let me reset this, okay, and here you say, all right, here I'm going to define is the is active and sec or active and sec active. You can say is active, yeah, set is active. Is active, set is active from the use state React that initially is false. Okay, and here you say okay, and I prefer to define all of the states here as it is. Yeah, much more better. Again, as a way to align myself with the mental model that React actually uses. Good, which is now import React set Jesus use use state from React. Okay. Import use state from React. Exactly. Import use state from React. So here we say this. If exactly, here's when we're going to define is our UI state, and I love it, man, and I love it because now I know what are the possible state that we can have here. Okay, we can say, hey, this state, you say, is active. Is this is active? Okay. I want now to return is this. If this is active, I want you to return is this. Okay? I want you to return is this. If not, okay, if this is active, which is of course false, true, if not, okay, then I want to return is this GSX, bro, which is now with this particular state. And again, this is now the React way of doing things, you know? This is the React way of doing things. Repetitive, yes. Less expensive, much easy to digest, totally. So if this, now we're going to remove is the background active, okay, and add is the picture active here. So when that happen, so when someone actually click here, okay, so now that we know is our different UIs, now that we identify is our different UIs, now that I identify our different UI, now that I identify our different UI state, or now that I identify our different UIs visual states, and then I determine what trigger those state change, okay, which is on click. Then I'm going to define is the state that represents or represent the state in memory, okay, or represent the state, the UI states, okay, the visual state, represent the visual state in memory with use state, eliminate redundant states, okay, eliminate redundant states, and then connect the event handler to set the state, which is here. So first we define is our different visual use state. Okay, we identify our different visual states. Then I determine what trigger those events or what trigger those state change, and it'll be here and here, in this case on click based on this. So on click, all right, this is now when you're going to trigger is this as an arrow function. We're going to pass this now to evaluate this set is active to false, okay, and we don't have to deal with event propagation in our case, and then and then here we're going to say, all right, I want you to now set this state as true. So React, we're gonna take that, update the state, and give me an update snapshot. Give me an update state snapshot here. Give me an update snapshot. Exactly, but it's clicking on without the background. Clicking on the image. Okay, you should expect that clicking on the picture remove the purple background. Okay, clicking on the image, say false. You're gonna show this. So because now this is when the image is here, clicking on the background sets to true. Okay. In clicking on the image, set to false. And there you got it. So this is quite interesting. Very, very, very interesting. Totally. This is quite very, very interesting. Very, very, very interesting here. A very, very interesting exercise, because here we have from the first hand how important it is to follow this particular React model, React way of how you can define of UI, okay, by identifying is the UI. All right. So by identifying is the UI, and then so identify the UI different states. Identify the UI different visual states. Then you take a look now at the first. You start with identify the visual different states. Determine what trigger those state change. Okay. Represent those states using the use states. Eliminate redundant states that you don't need to, and then connect the handlers to set the states. So, and I think this is a very interesting approach, because now it allows you to define is what'll be the UI states to render when something changed. It allows you to describe is the UI per state, reacting input with state. Profile editor, hell no. Profile editor. Here is a small snippet with plain JavaScript for that. Okay. You can define all of this in one element. Challenge 3. Refactor the imperative solution without React. Okay. 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 I think that was quite illustrative, man. I think this was quite illustrative, bro. Okay. It's because this is the React way of doing it.
DocuSign. Worky LLC. Telling agreement. This one. $25.56. Exacto, molde. Ciudad Autónoma de Buenos Aires. Molde 2556, Ciudad Autónoma de Buenos Aires. Molde 2556, Capital Federal. Company is a service agency based in New York and serves clients through the United States and globally. Companies decide to work with talents on various projects as needed and as set forth in a specific project proposal which shall be maintained on a mutually accessible online platform. Consider the exhibit here, the proposal. Talents decide to work. talent agreement.
Hmm.